All right, hey everyone, thank you so much for coming out. It is late on day 2, so I'm very grateful that you all made it to this. This is Serving Content on the Web from PHP to RSC and beyond. My name's Adam Rackis. This is a talk about how frameworks have evolved over the last decade or so, but we're not going to talk about superficial syntax because that's boring and it doesn't really matter. Instead, I want to talk about how frameworks have evolved to make better use of networks. What do I mean by that? To set the stage, I want you to stop thinking about your network as some simple thing against which you call fetch to quickly and reliably get data. That may be true when you're vibe coding a to-do list on localhost against an SQLite database, but in real life, your network is going to be a bit more like this. I want you to think about round trips across the network as the single most expensive thing your app can do, because most of the time it will be. I want to take a very, very quick tour back through history, what the web looks like all the way back in the 1990s. In the beginning, when you visited a website, the server would receive your request, read the URL, and it would send back a fully formed HTML page. We used to generate HTML on the server without JavaScript. And yes, I know we still do this, but it's less popular and it's less common. But yeah, you don't need JavaScript at all. Web servers have been doing this since day one. We used to use long forgotten obsolete languages like Perl and PHP. I'm kidding. And these sites could even be interactive, even way back then. And if you're thinking that you would do that with something like fetch, fetch wasn't added to the web until 2015. And if that 90s meme hits you really hard, you might be thinking about something like XML HTTP request object. But that wasn't added to the web until 2000, if you can believe that. And by the way, that's how you generate XHR code in 2025. Thank you, ChatGPT. And JavaScript itself wasn't even added to the web until 1995. Back then, if you wanted a website to be interactive, you would use a form. You would give your form a URL to send the form data to, give it an HTTP verb like post or get, and then when the user filled out your form and hit the submit button, all that data would get sent to wherever you told it to, and the whole page would post to that location and send you back either a new page or maybe the same page with some validation errors, whatever. If you tilt your head a little and squint, forms kind of were fetch before we had fetch. Fill out the form, and your whole page will post to that location and send you back some new content based on what you filled out. And even the page load is negotiable. Once JavaScript did come on the scene, tools like ASP.NET MVC allowed us to progressively enhance a form so that you could do all of that without the whole page posting back. JavaScript would catch the form submit, cancel it, and then do that under the cover so that the page would stay right where it was. And then long later, tools like Sapper and Remix came along and made those patterns popular again. But it's hard to build a rich, interactive experience with just HTML forms. So what do I mean by rich, interactive web experience? So this is the part of the talk where I get to show you what I work on at work. I work for Spotify, and I work for the Spotify for Artists app. And I've sent these slides up, and I got permission to share some screenshots of what S4A looks like. This is the site that our artists go on to manage, to look at their analytics, manage their whole stuff. But I need an artist to show, right? Because I can't be showing screenshots of Taylor Swift's, stream data and analytics. But I happen to know an artist who is on Spotify for Artists, Ken Wheeler. So just imagine you're a Spotify engineering vice president, and Adam Rackis sends you some slides to approve, and this is the first thing that you see. But he was a very good sport about it. So here's a few pages of S4A for Mr. Wheeler. Here's some listings of his tracks with some stream data. We have some data visualizations. This is his listener demographics. It's a massive sausage fest, as you can see. 94% dudes are listening to Ken Wheeler on Spotify. We have some data visualizations on his stream listeners. And of course, it's interactive. You punch the button, fill out the checkboxes, and we send some requests and update the data visualization. Here's what his profile page looks like. Let's take a step back and look at all the sources of data that are on this profile page, because that'll be relevant in a minute. If you start at the top right corner, that A inside the purple circle, that's the currently logged in user. That's me, A for Adam. We hit that. We hit an endpoint to retrieve the info for the currently logged in user. Going clockwise down, monthly listeners, we hit an endpoint to get that data. Artist pick. If you've ever been on the Spotify music player for an artist page, you might have noticed the artist pick. That's where the artist gets to select something that they want to feature for you. It might be an upcoming release, a recently released, maybe a re-release. Then going down, we've got more of his discography, and I lied, there's actually more sources of data. If you are a user who can access more than one artist, and I'm an employee, so I can access all the artists. That list on the left is your recently viewed artists. We hit an endpoint for that. And I'm not happy to admit this, but those navigation links in the top left, we basically have to hit a separate endpoint for each of those endpoints, for each of those navigation links, to see if the current user can visit that link for the current artist. It's a whole thing. Could we build that in PHP? Yeah, for sure. Would we want to? Today, maybe. You have things like Laravel, which are amazing, especially with inertia that you can tack on. So absolutely. But what about back in 2012? What would that have looked like? Generating the content on the server was easy. That's what we talked about a minute ago. That's what web servers have always done. They get the request and they spit out some HTML. It's easy. And don't let the data visualizations fool you. Those are just SVG tags. If the web server can generate HTML tags, it can generate SVG tags, no problem. But what about all the interactions? When you click the button, you need to get the click and then show the popover, and then you need to listen on click handlers for all those checkboxes, and then send a request, get the new SVG tags, and update your DOM. The artist pick, if Ken were to click there, we would sub in a little widget that would let Ken search through his discography to select something to set as his artist pick, hit save, and then that would update with the new artist pick. Generating the content in PHP would be easy. The problem is interactivity, and even then, it's not really a problem, and it's not that hard, but it's work. And we have tools that are really, really good for just that. Amazing tools. jQuery, yeah, great memories. Everyone loves jQuery. You never hear somebody complaining about jQuery. It's a great tool. So let's look at what that would look like. If you wanted to go down this road, you could use PHP to generate all your content, send it down to the user, and now we need to make it interactive, right? So boom, you slap jQuery on it, and now you go to town, right? jQuery is an amazing tool to work with. You can select any content within your DOM and update it however you want. The API is fluent. It's a pleasure to work with. The problem is it works on CSS selectors, which are global. Spotify for Artists is managed by about 12 different teams of software engineers. So your app gets really, really big, and those CSS selectors are global, so you have to take a lot of care to make sure that nothing conflicts with each other. And at scale, it gets kind of annoying. We have an impedance mismatch. You've got, in this model, your server being generated, your content being generated on the server, but all your code for interactivity lives on the client. And so you have to make them play well together. And we've spent a lot of effort over those years figuring out ways to do that. But at some point we said, why don't we just build the entire app on the client? And we started developing tools to let us do that. And then we developed better tools to let us do that even better. We said, let's just build this application one time on the client. We'll just sidestep the impedance mismatch. The server, instead of building all that content in PHP, we'll just spit out an empty HTML file that has a loading spinner, and then the client-side JavaScript will spin up and build our application. Since the server is only ever sending down a single shell of a page, we call these single-page applications. That's where the name comes from. So what's the problem? Not much. Ignore anyone on Twitter that says otherwise, but SPAs were great, and they still are great, and you can build an amazing product as an SPA, and you still can. And if your business failed, it wasn't because it was an SPA. And I'll double down on that. Sending down a few hundred kilobytes of JavaScript is not a problem. If your business failed, it wasn't because you had a few hundred kilobytes of JavaScript. SPAs will not work if your user has JavaScript disabled. Doesn't matter. Who cares? SPAs do suffer from bad SEO, so if that's a big concern for you, maybe think twice. But there is one substantial trade-off with SPAs, and it was hidden in plain sight the whole time. Remember I said our server sends down an empty shell of a page now? Well, that means that this becomes this now. When our server sends back our page, the user is just looking at an empty loading spinner. Our first render is now kind of useless. So the browser gets that empty shell of an HTML page, and it's going to parse it, and it's going to start seeing those script tags, and it's going to request those over the network. Maybe they're cached in a CDN close to you, or maybe they're not. Maybe they're cached in your browser if you've been to that website recently, or maybe they're not. Once the browser parses and reads that JavaScript, now your React components are going to come to life. And what's going to happen next? you're going to need to fetch some data, right? So that's going to be more round trips across the network. And eventually all that will finish and your app will start to display. And again, this is fine. Yes, it's a few hundred milliseconds. Unless you are doing heavy e-commerce or maybe some clickbait content slop, you're fine. This will be fine. But we're engineers, right? We want to do better if we can. It's not efficient. And so how can we fix this? We started building our entire app on the client, and the one thing we gave up was server-side rendering. And so now to get content in front of the user, it takes a little longer. So how can we fix that? You might be saying, well, this is a non-issue because React already supports server-side rendering. There are server-side APIs for React. It's not actually react.stringify, but conceptually that's what it is. It takes a component tree and it stringifies it into HTML. So on the server, you can stringify your app component tree into HTML and send that down the pipe. And then on the client, it gets the HTML and displays it. And then you use the client-side APIs, and it's not React DOM.render anymore, but that doesn't matter. You re-render the same component tree in the same place, and React will match everything up, and then it will spin up all your event handlers and effects, and that's called hydration. The problem is data, though. This is what it actually is going to look like because you have to fetch some data on the server in order to show something useful. And so at first it seems easier, right? Just fetch your data on the server and then pass your data to your component tree somehow. But then you have to do something unhinged. You have to take that data and you have to ram it into a script tag somewhere. Why would you do that? Well, because when you re-render your app on the client, you don't want those same components requesting the data because you already have it. You want to just read the data that was requested on the server and stuffed into your DOM somewhere. It's not hard, but it's really easy to get wrong. And this is where we start to see the evolution of meta frameworks like Next. If you ask most people about Next, they'll say like file system-based routing. But solving this problem is, for me, one of the cooler things that Next did. It gave us a place to request data on the server, and then it gave us a place to define our component for a given route, and then those data just magically show up in your component. And Next does all that unhinged stuff in the background. If you ever inspect the HTML page, you will see that server-side data stuffed somewhere into a script tag as some sort of global data. Huge step forward, but now each of those routes has to be aware of all the data that that given route needs. Remember all the pieces of data that we needed for any given page? That's going to be really hard to stick inside of this one function, get server-side props. And there's no way to invalidate with the old next pages directory. So like if you're on a page, there's no way to say, hey, I've updated some data. I want to rerun that get server-side props function and push new data down. And what happens as you browse around your page? If you go from /tasks to /tasks12 to view a task, and then you browse back, do we want that get server-side props to rerun or just use the cached data? There's decent arguments either way, and you might want either, but your framework is going to have an opinion. We start to get that impedance mismatch back. And now we get the next sort of generation of meta frameworks, Remix and SvelteKit. These gave us the same sort of idea with get server-side props, but as loaders, and you can define many of them, and they're attached to individual chunks in your URL. And each of those different loaders can request a little piece of data for that given segment of the URL. And they can be invalidated. You now have ways to say my data have changed, rerun all my loaders and get fresh data, or you can even say rerun an individual loader just to get those few pieces of data. And these frameworks even let you sort of make up your own loaders to split things up even more that have nothing to do with the URL. So you can really get fine-grained if you want to. Conceptually, here's what a loader looks like. If we're imagining like a Jira app, you might fetch your tasks and your epics and your milestones inside of a loader and send those down, and then your components can read it. But those loaders invalidate all or none, right? So if you were to edit, I'll get to that. And same as before, if you start browsing around and you come back to a page that you were at before, do you want to reuse cache data or do you want the server to rerun and refetch? You might want either, and the framework might have an opinion either way. So you have to be aware of that. And like I said about revalidation, if you were to edit a task and then revalidate your loader, everything is going to rerun. You're going to rerun your tasks, refetch your epics, and refetch your milestones, even though you don't need to, even though the epochs and milestones hadn't changed. This is fine, right? If that is what breaks your backend, then your backend was already broken. But remember, networks are unreliable, and the more pieces of data you're unnecessarily re-requesting, the greater the chances some of them might just be randomly slow for reasons that you have no control over. And yes, you can keep splitting up your data into those synthetic loaders that I mentioned, but that's going to get tedious. App directory inside of Next, React Server components. That seemed really encouraging. You can just fetch data right in your components, but it's sort of the same problem. Next gives you those cool methods called revalidate tag, and they make it look like you're only re-requesting those pieces of data that you revalidated based on the tag, but no, your whole component tree is rerunning. It's on a server. It might be a Lambda function that didn't exist 2 seconds ago. It has no idea what your client-side React component tree is. It's going to rerun your entire React tree on the server and re-request everything and send it down. All revalidate tag is doing is it's kicking some things out of the cache. Vercel is assuming that you're caching all of these data in a JavaScript layer, which might or might not work for you. Still great though. RSC was an amazing engineering feat, and it does fit very, very well for plenty of use cases, e-commerce in particular. But let's back up. Why can't we just kill this impedance mismatch once and for all? Remember how good life was in the SPA days? We had great data fetching opportunities, great data fetching tools. React Query. Who here uses React Query? I think a lot of you are lying. I think more people than that, but it's a very, very popular tool, about 15 million weekly downloads. It lets you do things like this. You can give it a hierarchical key. You can say epoch and then a given key, give it a function to fetch it and some cache settings. And then it gives you URLs to invalidate your data at whatever fine-grained level you want. You can invalidate an individual epoch or a whole family of queries and just wipe all of them out with the second one. That's how the hierarchical keys work. And you might say, well, why can't I use that with Remix? And you kind of can. There's this initial data property that React Query has. You can take your data from a Remix loader and just put it in a React Query hook like that. And that will take the server fetched data from your loader, and React Query will work with that just fine. But as you start using your app and the epoch ID changes, you need to be sure to remove that initial data so that React Query knows that I need to actually fetch the data. And then what happens when you invalidate your loader and it reruns and pushes you fresh data? Now you need to stick it back in as initial data again until you start using your app again and epoch ID changes and you need to pop it back out. It gets kind of annoying. Life was so good in the SPA days. We were building the entire app on the client. Wouldn't it be so great if we could just have our server render the initial path and then just sort of go away and leave us with a beautiful client-driven SPA like we used to in the good old days? And this is where we come to the latest generation of meta framework. Solid Start was first. I wish Solid had more traction. It's really cool. Tan Stack Start, though, that is, as of a few days ago, finally in release candidate status. I urge you to check it out if you haven't already. But it gives you isomorphic loaders. What does that mean? It means the loaders run on the server or on the client. They will run on the server for the initial run when the user first browses to your web app. And after that, as you keep browsing around the web app, they run on the client. And it's deeply integrated with React Query. Let's take a look. A lot of code here. You don't have to focus on really any of it except for the stuff that's circled. The top loader function is the loader for that path. And the bottom function index, that is your component. React Query gives you URLs, or excuse me, it gives you APIs like ensure query data. That lets us say, make sure this data exists for this path inside my loader. And on the server, ensure query data will pretty much just always fetch the data on the server, and it will do all the work behind the scenes to make sure that those data are available for your component, and it will be there for the initial run. And then on the component, we say use query. What happens as the user starts browsing around and comes back to this same page? Like I said, it'll run on the client for all subsequent navigations. And the query client, that matters because when we say query client.ensure data on the client, it will look at the client-side cache that we already have with React Query. So you can have 5 or 6 or 7 or however many calls like this in your loader. And as you come back to that page, you may have invalidated 1 or 2 of them using those same React Query APIs. And since this is running on the client, it will only re-request those few pieces of data that it needs based on what's cached, based on what you have kicked out of the cache. After the initial render, your loaders always run on the client. And that is significant because we have access to all the client-side goodies, our client-side data cache that React Query gives us. The impedance mismatch is basically gone. The server is just there to force down content quickly for that initial render, and then it just sort of gets out of our way and it gives us back the SPA that we've always had. Are there any downsides to this? If it wasn't for Dan Abramoff, I would have just gotten up here and say, this is just better. Sometimes one thing is just better than the alternatives, but there is one slight gotcha. If you screw up, your consequences will be a little bit worse. In Remix, if you have a data waterfall in your loader, it's not going to be that expensive because it's always going to be running on the server. And hopefully your web server is close to your database so that that latency is very, very, very small. But if that waterfall is running on the client, you're doing those huge round trips all the way across the internet. So just don't screw up, okay? Just don't do this. Don't have sequential awaits like that. Use promise.all or promise.all settled, and in reality, you'll probably want to be a little more robust than a stupid promise.all call. But conceptually, there's any number of ways to run code at the same time. And if you're saying, hey, my backend is kind of busted, I actually do genuinely need sequential calls like that, that's fine. Just put it in an API call somewhere, and those will always run on the server, an API route. And that'll always run on the server, and you call that API route from your loader. And then the waterfall will always run on the server. If your data are slow, all modern frameworks, Remix, Next, App Directory, TanStack, all of them support something called streaming. You can start your data fetch on the server, but not block the rendering, and then just push the data down when they're ready. How is that different than what we saw before with the initial sort of empty page? This is different because the data already do start to fetch as soon as you browse there, but we just don't block the render, and the server can push the data down whenever it's ready. Use it judiciously. If you stream every single piece of data on your page, the user is going to initially get met with like 20 loading spinners, and they're going to jarringly pop in. Maybe server render your main data and stream a few pieces of side data if you need to, if they're slow. Make sure there's no content shift, and so on. So this talk was not meant to be one framework is better than the other. What I was hoping the takeaway would be is to start to think about how your frameworks work and ask different questions than people sometimes ask. And if it seemed like I was ragging on Remix a lot, keep your eyes out for Remix 3, because I've heard they are adding isomorphic loaders. I've seen Ryan Florence claim that on Twitter. I hope that does wind up landing. I'm really sorry I didn't mention Nuxt at all, but I'm not a Vue person and I don't know anything about it. And Jessica's glaring at me. I've heard good things though, so check it out. Yeah, that's my talk. Thanks so much for listening.